All right, YouTube. Got another project. So we did the backup system. We did the transfer switch, undergrounded, solar panels, everything else. Now I noticed something. I have two of the bedrooms running on solar power year round. But I have a den which pulls too many amps for me to put it on my little solar system. I scale my solar system so I can get the best cost benefit out of it. That's 4 batteries, 4 solar panels, 40 amp inverter, 40 amp power controller. That's just enough for me to keep my batteries from decycling lower than 85%. Which is pretty good. You don't want it to get any less than 50. That's a killer. And if you go lower than that, well, you just ruin your batteries. So I cannot run any more on my little system other than some bedrooms. But I do have enough to temporarily run my den, which pulls an excessive amount of amps, but I can run it. I can run it as a backup system. I don't have to buy a UPS, a power little battery thing. I have one in my solar panel. So how do we do that? Well, here's how. These things are called arrays. I'm gonna power this down so I don't ruin everything. This is a cube array, a cube relay. And the way this works is you have a cube. I think this is a RP2P-U, and you can take a look at it here. What it does is it allows you to switch between these two outlets here. These two, a neutral, a hot, neutral, a hot. Lets you switch between the two. So what you do is you have an input. You have the input here, which is the coil. All right. And the way you read this is you go this way. You have this little key here. You see how this key is pointing downward? Well, that's the starting position. And you count like this. Key down. 1, 2, 3, 4, 5, 6, 7, 8. Once you place the key down, keyhole down, it's 1, 2, 3, 4, 5, 6, 8. Already 8. And then these pins correspond. This one is number 1. Which goes, I believe, goes to here. Number 1 goes to here. You could test it by doing continuity. Let's do a continuity just to make sure. We got a meter here. You hear the beep. I believe this is 1. Yes, this is 1. No, actually, this is 2. Sorry, this is 2. This is 1. All right? And 2 and 7 is the coil. 2 and 7. So this will be 8. This will be 7. All right? And this is important because you want to put a hot here, your control hot and neutral here to slam the coil. When the coil slams, you activate either this set or that set. All right? So this will be the power input, the input source. Then you're going to be switching this power input source from these two or those two based on whether you slam this coil with a control voltage. All right? So here we go again. This is keyhole, right? Point downward. It goes 1, 2, 3, 4, 5, 6, 7, 8. You use 2 and 7 to slam a coil, which takes 1 and 8. 1 and 8, okay? That's the reason why I was beeping is because I put these two together. Don't worry about that. You wouldn't hear it before, okay? Cube relay. 1 and 8. I'm going to power these two here. And I can't think of the numbers here. 2 and 7 slams the coil to switch between these two and that two. Now, you use a relay. And this is how we're going to use it. We're going to use a control supply, control power, to switch between AC and DC. I'm sorry, switch between AC mains and AC backup. All right? When the mains are up, this coil will be in the slam position. Coils will be in slam position. Okay? That means you're going to have flow going through. When the mains go down, the default state will be the backup power. So when it's up, when these are slam, I'm going to wire these so when it's a slam, you got AC flowing. AC flowing. When the AC goes down, they're going to go to the default position. In the default position, in the open position, you have continuity between these two and these two, the bottom two here. That's where continuity is, between these two and the bottom. When you slam this, when you close this, then you'll have continuity between this and this. So what you want to do is when in normal conditions, in the lines, when mains is up, you want to have power going from here to here. That's what I'm going to do. But then when the power goes down in the open position, I'm going to have backup power flowing from here to there. All right? Now, I could chop this video up, but I'm just going to roll through. YouTube now has a lot more megabytes to play with. Now, here's an interesting thing too. I have here a son-off. Here's a son-off, right? One more thing. What is this box for? Well, this is a transformer. And what happens is I'm stepping down mains voltage to 1 amp because the coil can only handle that. The coil can only handle 1 amp. All right? So you have to step this down. The controls has to be 1 amp. Because on this main here, you can get whatever up into including the breaker voltage. It's 20 amp breaker. I will fry this coil. So when you're doing controls on this cube here, I have to step the voltage down. So here's an interesting scenario, and I'm going to show you this in place. And once I go and put it in place, you'll see what's going on. Here's a son-off you can't see. I guess, sorry about that. It's right out of range. Let me put this within camera range. There goes the son-off there. And I would take this son-off just in case I want to control this system by voice. Well, I have a son-off here. I got it wired to the mains here. I got this control output, okay, here. And I'm sorry, but this is the way it is. You're not here in front of me, so you gotta kind of go with me here on this and try and move within camera range and back everything up. I think this is pretty much the center right here. All right, so got a son-off here. I send this out into the transformer. So now this is my control. All right, I go here to the control. And I'm looking for my screwdriver. Put it in. Give me some room. Let's see here. Give me some room. All right, jam that in there. Hold it down. All right. Bam. This is my control. And, this is an evolution of where we are as society. Back when the aliens landed on Roswell, sorry, I know I'm losing half my viewers with that conspiracy theory crap. We adopted a object-oriented look at nature. Before we were more procedural. Every day we would go and do an experiment to tease out of nature all of its gifts. Well, somewhere along the line, we got a whole lot of technology. And we started doing these solid state things. You see, these are relays too, but they're based on electric field on a more microscopic level. You have a semiconductor. The semiconductor gets filled with field, and based on how much field is there, it steps up resistivity or lowers it down, long current flow off and on. And that's based on the field. And of course, this happens on the field in a mechanical relay situation, but it's more gross. It's more grand scale. This is more like flow inducing a magnetic field on a larger scale that slams two mechanical contacts, whereas this electronic relay uses electromagnetic field to encourage the semiconductor to either be more resistive or less resistive, therefore controlling flow on a smaller level. It's the same deal. This deal is the same as this, but this is mechanical and this is electronic, okay? Meaning that it's smaller. You're dealing with smaller. Whereas this depends on the flow of electrons more so. This depends on the flow of electrons too, but on a lot smaller level. The mechanical part is actual material. It's a semiconductor. This one is two arms attached to a magnet that slams open and close. So anyway, that being said, this is how we're going to voice control or allow this system we recreated here to turn my electrical panel on and off the grid. And one more thing I'd say about this is that you want to do this at the transfer switch to make this safe, because if you do this inside of your box, you could kill an electrical worker or line worker, and that's a bad thing. All right, so I can't demonstrate at the same time the on-off interface with this because I'm using this phone to record this. So what I'll do is I'll use this button, and we're going to power this sucker up. All right, everything's clear. I don't have anything weird going. Just to demonstrate pretty much tutorial on this. Okay, so we're powering it up, right? It's powered up. See it flashing? Lights, yay, lights, right? We're going to test for continuity. We're going to test for continuity on our meter here, just to demonstrate where continuity is on the base state. Okay, there's continuity here. See this? Continuity there. No continuity here. Okay? No continuity there at the top screw. Continuity here. No continuity here. Top screw. There's continuity here. No continuity here at the top screw. Now, when you slam, when you activate this ice cube relay, and the button's out on this, I can't do it. This button's not working right now. So how am I going to activate that now? I'm going to do it. How could I activate that? Can I do it off screen? No, I need an app. All right, let me see if I can switch this sucker. I'm gonna have to cut back and forth, guys. Sorry about that. Let me cut back and forth. Unless I can activate this relay. No, I'm not gonna do it like that. Let me see here. Stand by. Okay, there you go. You can't keep an electrician down. All right, so here we go, right? I have this, got this here iPad. All right, and I'm going to show you how we're going to slam this relay with this here sewn off, okay? And so just to follow the process again, sewn off, transformer to the control lines of this relay. This is be the power source, which will be the DC. We're going out DC, the backup power system. This in the bottom two will be the backup power system. The backup power system here. Because I want to demonstrate how there is continuity when this relay is not energized, there's continuity between these two bottom ones here, okay? Continuity between these two bottom ones here, right? And when you slam this relay, see, there's no continuity between the top ones. It's the top one, bottom here, top here. No continuity. No continuity. When you engage this relay, okay, fail, please check the network. Try it now. Okay. All right. All right. All right. What's happening? You probably can't see it, but this is actually engaging. All right. When you see the red light, this is engaged. Red light there. This is engaged. Turn it off. No continuity here. I mean, continuity here. Yes, continuity. Watch. Engage it. No continuity here. Continuity up here. See it? Okay. No continuity here. Continuity up here. Turn it off. No continuity up here. Continuity down here. Continuity down here. All right. So that's the deal. We're gonna use the Sonoff, voice control, whatever, Google, Alexa. That's what it does through the EV Link app linking and Google Home app linking to activate this relay and take me on and off the backup system. Now, the benefit of doing it like that is if you want to use voice control. But normally, naturally, I can run mains through here. And whenever main is not energizing this coil, it's going to slam back into the default position, which would be the backup, the solar array. And why am I doing this? I'm doing this because oftentimes in the home, you know, you have all these UPS systems and the like trying to control your computer and stuff like that, to power your computer during power outage. You only need a little bit of time until mains come back up. Well, if you need that and you have solar, why not use that? You know, you already have backup power running through your house. So I'll show you this wired up later on, and see you then. Oh, by the way, this wiring occurs at the transfer switch. Do not go to the main panel with this. You do not want power running through the mains when power is off, because electrical workers are up there doing their thing, and here you got all these volts and amps going up there while they're working. You can hurt somebody. This happens at the transfer switch, and I'll show you how we do it. All right, see you in a minute.